Please don't. Okay. We're here starting chapter 5. Today's one of those days where it's a lot of nitty-gritty vocab, boring bleh kind of day. So just be really excited for it. You guys ready? That made you excited, didn't it? All right, so here we go. Chapter 5, I kind of have referenced it a little bit throughout chapter 4. This is the chapter where we will start looking at like more than just x squared. So we're going to look at x cubed, x to the 4th, x to the 5th, x to the 6th. So what does those high exponents, what's that mean for your number of answers when you solve? Yeah, so if it's an x to the 6th, how many answers do you have? Yeah. I'll be honest, I love this chapter. Love, 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 love this chapter. I don't know why, I just think it's fun. I love this chapter. No, people do well on this chapter because I will teach it to you. Okay? You'll be fine. I love this chapter. That's right. No, I do not have an untest for this. Nope, just the one. Sorry. All right, here we go. So this one, today we're going to start talking about, we're not talking just quadratics, we're talking polynomials. So things have higher exponents than just x squared. So first thing is you need to know what the word polynomial means. Okay? Poly comes from poly, which means many. Nomial means term, so many terms. That's what polynomial means, right? So this has 1, 2, 3. It's kind of like the chunks of a problem. Boys, are you with me? Anthony's not even back there to blame. You with me? All right. So the highest degree of a polynomial in one variable is the highest degree of its terms, which we kind of already know this. So this example, how many terms does this have? Has 4 terms, right? 1, 2, 3, 4. 4 terms, has a degree of 3 because the highest exponent is 3. Hard stuff today. The leading coefficient is the coefficient of the term with the highest degree. So this one, the highest degree is 5. The leading coefficient should be -8. Because what's wrong with the way this is written? It's not in standard form. We don't like the way it's written. All right, so the next thing we talk about is standard form. So what order should this problem be written in? This is hard stuff today, isn't it? Hard stuff. Today's an easy day. All right, so polynomial functions can be classified by their degrees or by how many terms they have. So here's where a lot of this little vocab comes in. So if I have, for example, the number 5. So what degree is that? 0, because there's no x on it at all, right? So this is a 0 degree, which we call this just a constant. It's just a number. How many terms does this one have? 1 term. Do you know what you call something with 1 term? Monomial. Very nice. Think of mano y mano, man on man, one on one. Yes. Yes. You got it. All right, so this one, this is x to the 1st. This is called linear. If you would graph that, it would make a straight line, linear line. Okay, so what degree is that? 1. How many terms does this one have? 2 terms, and we call that a binomial. The one that we're most familiar with, chapter 4 was all about x squared, which we call quadratic. That is a 2nd degree. How many terms does that one have? 1. You guys thought there was a pattern over there. Yeah, there's a pattern over there, not over here. And 1 term, again, is called a monomial. All right, cubic is x to the 3rd, or 3rd degree, cubic. All right, and then how many terms does this one have? 3. What do you call something with 3 terms? Trinomial. What'd you say? A tri is too hard? I think of a tricycle. It has 3 wheels. All right, x to the 4th is called a quartic. I always think of like 4 quarts in a gallon. Makes you remember quartic, 4. So fourth degree. How many terms does that one have? 2. We call that binomial. You guys have seen a lot of these words before, haven't you? And then x to the 5th is a quintic. Quintic, x to the 5th. All right, number of terms in that one? 4. What do you call something with 4 terms? Very nice, Paige. That is a polynomial. They're all called polynomials, but you have monomial, binomial, trinomial, and then there's no more specific name after that. I don't know. It just is. I don't know. It's a good question. I don't know. There are just more specific names, but I agree with you. You're like, mono means one. Many. It's not really many. Although one car to a family would be like many cars to them because they don't have one. It would mean the world to somebody who doesn't have one. I don't know. I'm stretching here. I don't know. I really don't. No idea. All right, here we go. Write each polynomial in standard form. Classify it by the degree and the number of terms. All right, we got this. So 3x plus 9x squared plus 5. What order should it be written in? 9x squared plus 3x plus 5. Good. That's the order it should be. All right, so classify it by its degree. What degree is it? Second degree, which is also known as quadratic. And then the number of terms, you would call this a trinomial. It's got 3 terms. All right, who wants to come up and do the next one for us? The one that starts with 4x. All right, Amanda, come on up. What? The one that starts with 4x? Okay. Oh, I thought I was going to be sneaky. She's smart. Good. What did she do that I thought might trick her up? Yeah, there's like terms up there. So she went ahead and put her x squareds together. She's smart. All right, and then classify it by its degree. So fourth degree is known as 4 quarts in a gallon. Quartic. Q-U-A-R-T-I-C. And then what would you call that thing? Polynomial. Good. It's got 4 terms. It's just a polynomial. Good. Huh? Who'da whata? No. No. I know what he's saying. Like if you ride a 4-wheeler, they call that a quad. Yeah, my brother used to race them. Sorry, I knew that. Yeah, 4-wheelers are called quads because they have 4 wheels. But a quadratic only is x squared. I know. English language, isn't it great? All right, who wants to do the next one then? 3x cubed minus x plus 5x to the 4th. I didn't ask for that. All right, come on up, Jacob. 3x cubed minus x plus 5x to the 4th. Okay, go right ahead and write it in standard form. Can't you see him as a teacher someday, like writing on the board? Sorry, Jacob. Good. 4th degree is known as quartic. Very nice. And by number of terms, you would call it, more specifically, it would be known as How many terms do you have? Oh, yeah, number of terms. How many pieces, how many chunks are there? Chunks? It's not a very nice nickname. Good. Very nice. And the last one, Jesse had said something first. We'll get you in there in a minute, Daniel. All right, Jesse, he wanted it. I laugh every year because somebody always makes the same mistake on this one. Stop it. No, that's a 4. Don't you feel bad for me? I got to grade his stuff. I write mine like that sometimes. There we go. Very nice. Very nice. At least you didn't do what every year people do. Every year people tell me it's already in standard form. They think that 3 is problem number 3, even though this is clearly the 4th problem. They still think it's problem 3. This is painful. He writes really slow. You were writing really slow. Oh, look at his fanciness. 5th degree. Fancy. I appreciate that as a lazy mathematician. All right, so 5th degree, what do you call a 5th degree? Quintic. Quintetic. Quintic. And what would you call that thing by the number of terms? Right? Very nice, Jesse. That is correct. Questions on how this stuff works? Easy stuff, right? Easy day. All right, here we go, guys. Next part is talking about their graphs. The graphing calculator will be your best friend throughout this chapter. Okay? It will truly be your best friend. All right, so characteristics of all the graphs that you're looking at, they will be continuous, no breaks, no holes, no gaps, no sharp turns, very smooth, rounded, beautiful graphs. Okay? So let's talk a little bit about what these different graphs look like. Okay? Because I have it for you on a separate sheet of paper. Sorry. There we go. Now we're good. I forgot. All right, x to the 6. Look like a parabola. Negative x to the 6. Nope. Nope. I know there's questions. You're like, wait a minute. Like, why do they all look the same? So which ones look the same? Evens look alike and odds look alike. Okay? Isn't that odd? Isn't that funny? All right. So what that leads us to is this end behavior in a nutshell, which you guys will need to know. Behavior in a nutshell. So you recognize the evens look similar, the odds look similar. Do they always look alike? Exactly the same? Nah. They look different, but what's the same on them is their end behavior, meaning the ends where you put the arrows on them, where they're pointing up, down, whatnot. So even exponent ones, right? Even and odds referring to the exponent, not the coefficient. If they were even and positive, they were smiley faces, right? And if they were even and negative, they were sad. And that's exactly how I remember that. If I'm an even-keeled person, you guys ever heard that term? You're even-keeled? Even-keeled person means I'm kind of smooth, I'm level-headed, whatnot, and I'm positive, I'm going to smile. But if I'm an even-keeled person and negative, I'm going to frown. Helps me remember this, because you need to have this memorized. It's not hard to memorize. And then if your exponents are odd, you're kind of an odd fella. So when you're positive, you go from left to right. You look like you're going up, but your smile's not really normal. It's kind of odd, right? See? Stupid things help you remember things, I'm telling you. And if you're odd person, your smile's not normal, but from left to right, it goes down, negative. Mm. Odd negative person, you can be lonely. Yes, yeah, you had a stroke. So you look a little odd. I had a stroke. Oh my gosh, I remember my first day of one of my math classes in college. We walk in and this teacher's teaching, and like the one side of his face like never moves. Like his eyes did, but like his mouth didn't. And like at first I'm like, well, maybe he went to the dentist today. You know, like if you get a filling in like the one part of your mouth, I'm like, maybe he just went to the dentist today. He never said a word about it, just went on. The next week I come in for class, still look like that. So I don't know if he had a stroke or something. But then I felt bad because I laughed behind his back, you know, the week before. So I felt bad. Anyway, but yeah, that's kind of what his face looked like. Kind of odd. He was a great teacher, nice guy, but odd. Yeah, it could be. Yeah. All right, so here we go. So, okay, can we finish? Okay. All right, so here we go. So how all this we're using, so I have that kind of chart right out there in front of you, is I can tell just by looking at an equation kind of an idea of what it looks like. I don't know exactly, but I have a general idea of how the graph looks. So on something like this, I want you to describe the right and left hand behavior. It's referring back to this chart. Because on this chart, the left side of this graph is going up, and the right side of the graph is going up. See how left and right works? Here, the left is going down, and the right is going down. Over here, the left is going down, and the right is up. And here, the left up, and the right is going down. Oh, that really doesn't look like it says down. All right, now the whole reason some people try to memorize left, up, left, down, like all the left, right, up, down, that's confusing. For me, it's easier to remember what the picture looks like, and then I can tell you what the left and right are doing based on my picture. That's just easier for me. So if I look at this first one, I have an odd exponent. So right away, odd exponent tells you it's the squiggles, and the number in front of it is positive. So is it squiggle up or squiggle down? It's going to be squiggle up like that, right? Because the number in front's positive, and the exponent's odd, so it's a squiggly one. Good. So left down, right up. Give me an L and an R. Because sometimes people try to argue, I had it right, I went left, right. And they're like, no, I went right, left. And like, then they argue with me. Just give me an L and an R. You can even draw me arrows. L, arrow down. R, I mean, that's totally fine. I'm cool with arrows. Did you do arrows? What did you even answer it? Oh, over here. You made a T-chart. Hey, I know what you mean, so I'm cool with that. Jesse? Mm-hmm. Yep, totally fine. I'm cool with that. So what about the next one? X to the fourth minus 2x cubed. Your exponent is even, so you're either smiling or frowning. Which one's this doing? Smiling, because the number in front's positive. So left is going up, right, also up. All right? How about the next one? Your highest exponent is odd. So what's this mean? Smiley frown or squiggle? Squiggle. Is it squiggle up or squiggle down? Because some of you are like panicking, but really this number would have to be distributed. So it would make it a negative 1/3 x cubed. So it's squiggle down. So left is going up, right, down. So we can get a rough idea of what the graph looks like. Last one over here. What's this going to look like? frowny face. So left and right. I got even lazier. I can do that with you guys. I got lazy, real lazy. Yeah. You guys cool with that? Figured you would be. Take a minute once you guys do these 4 on your own. All right, guys. So what about number 1? What'd you decide? What'd it look like? What's it? Good. Right, it looks like that. So left and right are both up. Number 2? Squiggle down. So left, right. Yeah, it helps be in the right problem. Number 3, what's that look like? Squiggle up. So left, right. Number 4? Round face. Left and right. Down. All right, questions on end behavior. Yeah, not too bad. All right, here we go. This back to the question of why does x to the 4th graph look like x squared graph? Why does that happen? Okay, that's in its most basic form. It looks similar, but once you start putting other numbers into the equation, you know, if I had like x to the 4th minus 5, you know, 3x to the 4th plus x squared, da da da, like as you get things going, different stuff happens to your squiggly lines. So if a polynomial has a degree of n, so 4th degree, for example, then the graph has at most n minus 1 turning points. So we're going to kind of look at this both directions here, okay? So this right here has 1, 2, 3, 4 turning points where it changed from going up to down or from down to up, right? Turning points. So if it has 4 turning points, let's write this out. Turning points plus 1 equals degree. Or you can think of it backwards from that, where you could tell me that the degree minus 1 equals turning points. Right, it kind of depends on what you're given and which direction you're kind of going with that. So turning points plus 1 equals degree. Or degree minus 1 is how many turning points it'll have. Now, notice in the direction, though, it says at most, where we looked at that graph of x to the 4th. How many turning points did x to the 4th have? It could have how many? Try again. It could have 3. But when you graphed it on the one I asked you to graph it, how many turning points did it have? It only had 1. At most, it could have is 3. So depending what else is with that equation changes what that thing is doing. But it's never going to have more than 3 turning points. This is a 5th degree. So let's go back and look at some of the problems that we just did. Let's talk turning points. So if this is 4th degree, how many turning points will it have? At most, degree minus 1 is how many turning points? So this would have, at most, 3 turning points. I'm being lazy again. 3 TP. That's kind of fun to say. All right. All right, so this is 5th degree, so at most, how many turning points? I'd have 4 turning points. This is x to the 3rd, so how many turning points? At most, 2 turning points. And this would have, at most, 1 turning point. Okay. It is. All right, real quick, before we get to that. Let's say I might give you a graph. And I give you that. What degree is that? How many turning points? 1, 2, 3, 4. Turning points plus 1 is degree. This is a 5th. All right? Isn't that fun? So 1, 2, 3, 4, 5, 6, 7 plus 1. This is an 8th degree. Yeah. And I can ask you to solve that. And you can find all 8 answers for me. Won't that be fun? That's in this chapter. Right now, no, we've not learned how, but I will teach you. Nope. We'll end up taking these crazy equations, whatever degree they are, we'll graph them. Graphing calculator, looking at the graph of them can tell me a lot of the answers. And then I can reduce it down to an x squared, so then I can use one of my 4 methods to solve it. All right, so what we're going to do, human tic-tac-toe time. We've done that before. But we're going to do this, boys versus girls. So I need girls on that side, boys over here. Focus. Girls over there, boys over here. Girls over here, boys over here.